So here we have another fantastic PowerPoint written by the one and only Dr. Frost. Miss Hayden Higgins Worked Solutions. Okay, we're just having a quick intro. Part A plus b to the power of 0. What do we know about anything to the power of 0? 1, absolutely. Then, a plus b to the power of 1 is literally just a plus b. Then for the second one, we have a plus b squared. Now, if I was to expand this, I would get x squared plus 2ab plus b squared. Then, a plus b all cubed. If I was to expand and simplify this, I would have a cubed plus 3a squared b plus 3ab squared plus b cubed. So, when we're finding the expansion of 2 plus 3x, in essential, our a and b here, our a is 2 and our b is 3x, okay? Now, we know for 4, we know Pascal's triangle is 1, 4, 6, 4, 1. And if you do not know how to find those terms, you know in your calculator, this is 4C0, 4C1, 4C2, 4C3, and 4C4. This is how you could work out your coefficients, okay? So, this is how it always starts. Step 1, we start with 1. Multiplied by our A. So our A is blue. Okay, so it's multiplied by our A to the power of 4. Multiplied by our B to the power of 0. Because 4 and 0 add up to the total power of 4. That is plus, our next coefficient is 4. Multiplied by 2 to the power of 3, because we're going down, descending in powers. Multiplied by our 3x to the power of 1. Because our powers, 3 and 1, need to add to make 4. So then we're going to have plus 6 multiplied by 2 to the power of, oh golly, I've used the wrong colour. 2 to the power of 2 times 3x to the power of 2 plus 4 lots of 2 to the power of 1 times 3x to the power of 3 plus 1 lot of 2 to the power of 0 times 3x to the power of 4. Now, something to note here. Obviously, in an exam, or if we were working this out, if I was doing this, I would probably leave out 3x to the power of 0. But this is the formula, okay? So you can see the powers all add up to 4, okay? Then we have the coefficients in order. Now again, you are going to see 4C0 here instead of 1. But we know that 4C0 is 1. So now what we can do is actually work this out. 1 times 2 to the power of 4 times 3 to the power of 0 is 16. Plus 4 times 8 is 24 times 3, 72? 72x.
8 times 4 is 32 times.
Oh, I did 6. What's 8 times 4? 32. Times 3? 96x. Plus 6 times 4? 24 times. Now remember, 3x squared, this is a 9. So 24 times 9? 216x squared, plus 4 times 2 is 8, times 3 cubed is 27. 8 times 27. 216 again, perfect. Then we're going to have plus 3 to the power of 4, which is 81.
Yeah.
81x to the power of 4. Amazing. So there we go. Now, I haven't really done too much explanation because we've explored how to find this, and we should all be fairly comfortable putting these numbers into our calculator. Okay, another example. So we know if it's to the power of 3, it's 1, 3, 3, 1. In this case, we're going to have 1 times our first term, which is 1 cubed, times our second term, which is minus 2x to the power of 0, plus our third coefficient is 3 times 1 squared times minus 2x to the power of 1, plus 3 times 1 cubed times, it's not cubed at all, I'm descending here, 1 times minus 2x squared plus 1 times 1 to the power of 0 times minus 2x cubed. So we should have as our final answer 1, because 1 times 1 times 1 is 1, plus 3 times 1 is 3, times minus 2 is minus 6x, so this is not a plus at all. Minus 6x plus 3 times 1 is 3, minus 2 squared is 4, 3 times 4, 12, plus 12x squared. Now normally if it goes 1 minus plus, the next term is normally a negative because we're going to have a power to an odd. 1 times 1 is 1, minus 2 cubed is minus 8, so this is minus 8x cubed. Okay, so I'm going to explain this in a lot more detail now. This, if you're happy with this, move on to the next slide. If you're not happy, have a look. So here, this is to the power of 3. So I know in Pascal's triangle, these are the numbers, the coefficient from Pascal's triangle. If I do not know how to get these, I can use my calculator, the NCR button. This is the first term, we'll start with 3. The second term will have a coefficient of 3. The third term a coefficient of 3, and the last term a coefficient of 1. Then, for your first term, this one here, this one is going to be in each term. But the powers are going to start at 3, 2, 1, 0. They're going to descend. And the first term is always going to be the highest power. Then our second term, now it's minus. If it was a plus, you wouldn't have to include the sign because it's a positive number, but this is a negative. This is what is also going to be in each term. But in this case, the power is going to ascend, starting at 0, 1, 2, 3. Now, the highest power you have is the power here, 3. Okay? And these two powers will not exceed 3 if we add them. 2 plus 1, 3. 1 plus 2, 3. 0 plus 3, 3. 3 and 0, 3. If you don't want to write this term to the power of 0, that's completely okay. But this is to understand exactly how it looks. Okay, so we know straight away that 5 is 1, 5, 10, 10, 5. Okay, now if we think about the formula, okay, this is going to be 1, and then what's going to happen? We know we're going to have a to the power of 5, and this is our a to the power of 5, isn't it? And this is b to the power of 0. This one we're going to have a to the power of 4, b to the power of 1. A to the power of 3, B to the power of 2. Right. What does it want? The coefficient of x squared. So I want this term here. So I don't need to mess around by expanding everything. I know I'm going to do this. So this is going to be 10 multiplied by a 2 cubed times minus cx to the power of 2. Okay? So I'm going to get 10 times 8 minus cx squared is c squared x squared. And this equals 720x squared because the coefficient of x squared is 720. So technically, 80 c squared equals 720. C squared equals 9. So C could equal plus or minus 3. So, we are going to look at factorials. So, what is a factorial? So, for example, 7 factorial. Oh, sorry everyone. Got it on chalk mode. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? This is what it means. So if I was to say 3 factorial, what does 3 factorial mean? 3 times 2 times 1, which is 6. Right then. So, in our calculator, when we're trying to find the exact number position from Pascal's triangle, we use the NCR button, yeah? Now, this NCR button, I know you might be thinking, this is magic. It is magic, but how is this magic done? Okay? How does the calculator know that if you were to do 5C2, the answer, oh no, let's do 5C3 actually. No, 5C2, the answer, how does your calculator know the answer is 10? How does it know that? For those of you who like computer science, surely there must be some coding in the background going on. You input a value, it does something, and then it will output a value, right? Okay, what is it actually doing? Now this is what it's doing. So, we're saying n choose r. That's what NCR means. N choose r. So, in our calculator, the calculation it's doing is n factorial divided by r factorial n minus r factorial. Now, we need to know this because we will get certain questions which will use this, and we're going to come to this in a minute. Some notation you might see is NR. So here, where it's 5 choose 2, this can be written as 5, 2, like this, in vector form essentially. Yeah? But it's not. But you might see it look like this. So, for example, if we were to do, so let's just use our example 5, 2. We're going to have 5 factorial over 2 factorial multiplied by, and then n minus r, which is 5 minus 2, isn't it? 3 factorial. Okay? Now, if I was to write this out, I'd get 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. Okay? We can actually cancel this out, can't we? We can cancel 3, 2, 1. And then this is going to leave us with 5 times 4 over 2 times 1. 5 times 4 is 20 over 2 equals 10. Now our calculator does this, but we also need to understand what's going on. Now, I want you to calculate these. You're not allowed to use the NCR button. You have to either use factorials or your brain. Okay? For example, A, 5 factorial. We know 5 times 4 times 3 times 2 times 1, which is 320. I was going to say, that sounds a bit much. Yeah, 120 sounds about right. Well done. Okay, 5, choose 3. I don't know why I've put a fraction, sorry. Okay, we know this is 5 factorial over 3 factorial times 2 factorial. Okay, now you can put that into your calculator if you want. But essentially, we're going to have 120 divided by 12, which is 10. There's a factorial button on the calculator for those that did not know that. Okay, so 0 factorial, you'll find when you put this into your calculator, you get the answer 1. Now this is going to become a bit more apparent as to why, when we have a look at a question where we're going to have C, choose 1. Okay, so down to question, C, choose 0, which is E. Okay, so we'll come to that in a second. So for D, we're going to have 20 factorial. So 20, choose 1. Okay, how many ways are there? What we're going to do? 20 factorial over 1 factorial and 19 factorial. Now, you know that 20 is essentially 20 times 19 factorial over 1 factorial times 19 factorial. So these are going to cancel. And you're going to have 20 over 1, which is just 20. Okay? Now, back in my day, when I did A-level, we had to do this without a calculator. But when you do this without a calculator, you get understanding, because you can see how you can manipulate it. Okay, you don't have to sit there and work it out. Okay, part E. 20, choose 0. We're literally saying, how many ways is there to choose nothing? Okay. Now, if we were to put this in the formula, we'd get 20 factorial over 0 factorial times 20 factorial. But we know from Pascal's triangle that 20 choose 0 is 1. We know that 20 factorial over 0 factorial and 20 multiplied by 20 factorial, the 20 factorial is going to cancel. So we're essentially going to be left with 1 over 0 factorial. Needs to equal 1. So therefore, it stands to reason that 0 factorial must equal 1. Okay? So n choose 0 is always 1. Okay, this provides our justification for this. Now, this is a very loose proof, as in, this is for your understanding right now. The proof of this is much more difficult, has a lot more justifications. It's essentially, this is a proof by contradiction. Okay? Okay, so if the power in the binomial expansion is large, for example, it's to the power of 20, it's no longer practical for you to draw Pascal's triangle, which is why we use the NCR button. Okay? So, we know if we were to write Pascal's triangle in terms of our computer calculation, we're going to have 0, 0. Okay, this is the 0 row. Okay, the first row is 1, 0 and 1, 1. Then we're going to have 2, 0, 2, 1, 2, 2. Then we're going to have 3, 0, 3, 1, 3, 2, 3, 3. And if you were to put these in the calculator, you know this is going to output our triangle. 1, 1. 1, 2, 1, 1, 3, 3, 1. Okay? So we need to know they completely correlate with this. So, I just want us to have a quick look at question 10. So we've already really looked at using this binomial expansion because we did our investigation, didn't we? Okay, and this time it wants the first 4 terms in the expansion of 3x plus 1 to the power of 10 in ascending powers of x. Okay, ascending powers. So if it wants this in ascending powers, we want our coefficient and our x to really, we would always put this here, wouldn't we? Because this is one that starts to the power of 10, this is the one. So you can rearrange this, and you can say this is 1 plus 3x to the power of 10. Yeah? Because we want ascending powers. Now, how are we going to write this? We know this is to the power of 10. So this is how I would write this to begin with. We want the first 4 terms. This is essentially how I'm going to calculate everything. So 10 choose 0, which we know is 1 anyway, multiplied by 1 to the power of 10 multiplied by 3x to the power of 0. Okay. Over time, I'm not going to write that. But that is our first term. Everyone happy? Second term, plus 10 choose 1 multiplied by 1 to the power of 9 multiplied by 3x to the power of 1. Next one, plus 10c2, 1 to the power of 8 multiplied by 3x all squared, plus 10c3 multiplied by 1 to the power of 7 times 3x all cubed. Now I'm going to work this out. 10c0 in my calculator is 1 times 1 times 1. So my first answer is 1. Plus 10c1 is 10 times 1 times 3x, 30x. 10c2, no, I actually don't know this. What is it? 45 times 1 times 9x squared. 45 times 9? 405x squared. The next one, what's 10c3? 120 times 1 times, and 3x all cubed is 27x cubed. So 120 times 27? 3,240x cubed. We have now expanded in ascending powers of x. Now, you don't necessarily have to write it this way round, 1 plus 3x. You can keep it as 3x plus 1. You can just change it so your 3x starts from 0 and your 1 starts from 10. As long as you're happy, you know, here's our kind of rule. Okay? Now, this only works, by the way, this rule only works if n is a natural number. Okay? Not a natural number. It is a natural number, but in your case, it's a positive number. Okay? This doesn't work for negative numbers or fractions. We have another formula for that, which we'll look at next year in pure 4. So again, now I'm going to write this in a slightly different way, but it still means the same thing. We know for the first term it's 7 choose 0, multiplied by 2 to the power of 7 times minus 1 over third x to the power of 0. I'm not even going to waste my breath writing that. Plus 7 to the power of 1 times 2 to the power of 6 times minus a third x to the power of 1 plus 7 choose 2 times 2 to the power of 5 times minus a third x all squared. We know the first one is just going to be 2 to the power of 7 because 7 choose 0 is 1 times 2 to the power of 7 is 128. 7 choose 1 is 7 times 2 to the power of 6 times negative a third x. Okay. I'm going to get minus 448 over 3x. And then plus 7 choose 2 times 2 to the power of 5 times minus negative a third squared. It's going to give me 224 over 3x squared plus ... is what we normally write. If this said to me, okay, if I said to you, I've got b plus x to the power of 5, okay, and I wanted the coefficient of the x squared term. Okay, so if you think about, I want the coefficient of the x squared term. Could you write a formula for this without having to do all the things? Okay? And the answer is yes, you can. The formula for this is, when I have x squared, if I think about this, this is going to be x starts at 0, 1, 2. So this is the third one along, isn't it? So this is going to be 5 choose 2, because remember it goes 0, 1, 2, multiplied by, and remember, if we want our x, we want this squared, we know the powers have to add to 5, so then we're going to have b to the power of 3. So this is the formula for the expression which is going to give us the coefficient of x squared. Okay, so here we have a plus x to the power of 10, okay? I want the power of 3. So I know straight away that this is going to be x to the power of 3. If my total power is 10, I know this one must be to the power of 7. And this is my a. And then I also know that if it's 10, it's going to be 10. Choose. Now, funnily enough, I don't know if anyone's noticed this, but we actually choose the power of the right, the power of the x. So if you look, this is going to be here, it's 5 choose 2. It's 10 choose 3. Okay? And here you can see why. NR is given by a to the power of n minus r, b to the power of r, where our b is what we're doing in ascending powers, is normally where we put our x. So for our 2x minus 1 to the power of 75, I would, again, rearrange this to get minus 1 plus 2x to the power of 75. Okay, we know we want our x to the power of 50. So that means our minus 1 must be to the power of 25, because our total power is 75, multiplied by, we know this is 75, choose 50. For the next one, it's in the right form. I know I want to the power of 7. So, this is going to be minus x to the power of 7. That means my 3 must be to the power of 5, because 7 plus 5 must equal 12. So then we know this is going to be 12 choose 7, because our x is to the power of 7. Okay? And then for the last one, again, I'm going to rewrite it in this form. Plus 3x to the power of 16. And we want cube. So we know this is going to be 16 choose 3, multiplied by, we're going to have 3x to the power of 3, so that means our 4 must be to the power of 13. So here we go, getting a single term of the expansion. So it tells us the coefficient of x to the power of 4 and the expansion of this is 3,360. Find the possible values of the constant q. Okay, step 1. What is the formula for finding the coefficient of x to the power of 4? If we have 1 plus qx to the power of 10, okay, to find the coefficient of x to the power of 4, straight away we know this is qx to the power of 4, do we not? We know this is going to be 10 choose 4, and we know we're going to multiply this by 1 to the power of 6. So this is 10 choose 4 is 210 multiplied by 1 to the power of 6 is 1, multiplied by qx to the power of 4 is q to the power of 4, x to the power of 4. This gives us 3,360 x to the power of 4. Now, we don't actually have to write our x to the power of 4 because we're just dealing with the coefficients essentially, okay? We know that they both have this. So that means we're going to have 210 q to the power of 4 equals 3,360. Q to the power of 4 equals 3,360 divided by 210. 16. So q to the power of 4 equals 2. So q to the power of 4 equals 16. The fourth root of 16. That means that q can either equal 2 or q equals negative 2. Okay, remember we could raise a negative to an even power, okay, and we will get the same solution as raising the positive of that, okay? Okay, test your understanding. Off you go. So, we know the in this question, we know the coefficient of x cubed is double the coefficient of x squared. So we need to write our formula for both. To find the formula for x cubed, we know we're going to have 10 choose 3 multiplied by 1 to the power of 7 multiplied by ax cubed. And then the coefficient of x squared is 10 choose 2 multiplied by 1 to the power of 8 multiplied by ax squared. Okay? So in actual fact, 10 choose 3 is 120. So we're going to have 120 a cubed x cubed. So this is 45a squared x squared. So we're going to have 120a cubed is double of the coefficient of a squared, x squared. So we're going to get 120a cubed equals 90a squared. A cubed equals 90 over 120, which is 3 over 4, a squared. So a equals 3 over 4. So, part A we should all be fairly confident with. 1 plus x over 4 to the power of 8, and what we're doing is the first 4 terms. So we know the first term is going to be 1. The second term, now remember it's 8, so we're doing 8c, and the first one is 0, and 8c 0 equals 1, okay, times 1. Now we know the next term is 8c2, which is in fact 8, multiplied by 1 to the power of 7, multiplied by x over 4 to the power of 1. Okay? You notice the first term in a binomial expansion is normally 1, if this is 1. I've just done this in my head. Okay? The second term is 8c2, 28, multiplied by 1 to the power of 6 x over 4 squared. And then the third term is 8c3, 36, 56, lots of 1 to the power of 5 x over 4 cubed. So if I simplify this, I'm going to get is approximately 1 plus 8 over 4, which is 2x, plus 28 over 16, 14, 7 over 4, x squared, plus 56 over 64, which is 7 over 8, x cubed, plus ... So there we have, we've expanded it, and that is 4 marks, and to be honest, that's a very easy 4 marks, okay? Now, the next part says, okay, use your expansion to estimate the value of 1.025 to the power of 8, okay? So this means we've got to use what we've done. We've got to use this, okay? Now, 1 plus x over 4 must equal 1.025. So 1 plus x over 4 equals 1.025. So that means x over 4 equals 0.025. So x equals 0.1. Now what I do is I'm going to substitute this value of x into what my first 4 terms of the expansion. Because it says in part B, use your expansion to estimate. So now what I'm going to do is I'm going to write, this is going to be approximately 1 plus 2 lots of x, which is 0.1, plus 7 over 4 lots of x squared, plus 7 over 8 lots of x cubed. So this is 1.218375, and I've written down the whole calculator display on my from my calculator, and it says give your answer to 4 decimal places. So it's approximately 1.2184 to 4 dp. Now, what I also want you to do is I want you to put into your calculator 1.025 to the power of 8 and have a look at your approximation. This is how you can double check that you are on the right lines. It should be fairly similar, and it is. What is it? That's the same thing. Perfect. So we've got quite a good approximation. Brilliant. So, test your understanding. Here is a typical exam question. 7 marks for this question. Off you go. Okay, so part A, the first 4 terms, we should be fairly confident now. This is 10. So just again, for the first one, 10C1 is what we're going to put in the calculator. But, the answer is 1. 10C0 is the first one. This gives me an answer of 1. Now, normally the first one is always 1, but it's this multiplied by 1 to the 10 multiplied by x over 2 to the power of 0. Now, I wouldn't normally write this in my exam question. I would just write 1, because I know this is going to equal 1. Then I'm going to have 10C1. I know that 10C1 equals 10. And then I'm going to have x over 2 to the power of 1 plus 10C2. Now, I'm not sure what that equals. 45, but I can put it in my calculator. How many? First 4 terms, 1, 2, 3. And then 10C3, 1 to the power of 7 and x over 2 cubed. So this is going to equal 1 plus 5x plus 45 over 2x squared plus, what is 10C3? Oh, what an absolute silly mistake. It is over 4, because x over 2 squared is x squared over 4, plus 60x cubed. 15? What's 15 times 8? (120 over 8x cubed). Okay, now 120 over 8x cubed is going to simplify to 15x cubed. Okay, so now I've got them all in their simplest form. Make sure you write the approximate sign. Okay, then it says use your expansion to estimate the value of. So in this case, we're saying that 1 plus x over 2 equals 1.005. So we need to find out what x is. So 1 plus x over 2 equals 1.005. X over 2 equals 0.005. So x equals 0.01. Now I'm going to substitute that in. 1 plus 5 lots of 0.01 plus 45 over 4 lots of 0.01 squared plus 15 lots of 0.01 all cubed. And this is going to give me, I'm going to write them all down first. 1.0511400132, and then, thank you, we're going to do 5 decimal places, 1.05114. Nice and easy, 7 marks.